So hello guys, welcome back to my channel, and it is the part 2 of our data analysis of our data science project, which is about student depression prediction. So since in the past video we have covered data cleaning, data pre-processing, not data pre-processing, we have covered data cleaning and exploratory data analysis, in which we saw that what are the main reasons behind the student depression. So in the last video, I have covered the univariate analysis, but we have to cover multivariant and bivariant analysis, and it's a task for you to do it, because I will not cover it all because this video will be quite so long. If you don't know how to cover, then you can watch my video of EDA. There I explain how to perform the EDA. It's a 38 minutes video, and it will give you it will give you the special ingredients to perform the EDA, and you don't need to watch the other video if you watch that my video. So since we will go with the df dot head to read the data here, and after reading the data, now what we will have to do, we will first of all perform the data pre-processing on the data. So first of all, what you will do, first of all I will check the columns. I think these columns don't need I think there are some columns which needs to be converted into it needs to be pre-processed. So for this purpose I will upload a library from scikit-learn dot pre-processing, import label encoder. Okay, label encoder here. Okay, so we are loading the label encoder here. Okay, okay, so we will import that we will call the object of label encoder here. So we will pronounce it as label encoder. Okay, so I will also mention here that calling object. Okay, label encoder. Okay, okay, we have called the object. Now what we will do, we will take all the categorical features and we will convert it into a numerical features using the pre-process into numerical features. Okay, we will label it with the numbers as 0 1 2. Okay, based on their order. So here I will have an idea. You can go it perform it one by one, but I will give you an idea here. What will do, you will create a new variable, new data frame here, which will called cat calls, which means categorical columns. Okay, so here you will select tf dot select d types. Okay, in the select d types you will have to include object. In a sense, it will select all the columns that are of object data type. Okay, object data type means they are actually a strings, not a numerical variable. So after that we will iterate through these things. We will iterate through for columns in cat calls dot columns. So when we iterate this, every column will initialize into this column one by one. At first iteration, it will be the first column gender, then it will be city, then it will be profession. Okay. Now what we'll do, we will take we will actually convert these columns lb.fit transform into, we will convert the column, we'll convert the cat columns cat categoricals value of columns into a numerical value. We will convert this into a numerical value, and we will store it in the df at the place of that particular column. So what we will do, let me tell you, wait a second. Okay, so it will first of all take this column from the cat call. It will apply the fit transform, and then it will replace that column at the place of the column which are in df, the same at the place of the same column which are in df. So in the df I have gender. It will take the gender from label encoder, it will perform the transformation, and it will store it at the place of the gender at df. Okay, so let's run it here. Now if I run it here, now it has been done. Let's check it here. Now everything have been pre-processed, and for your kind information I will also tell you what are the cat calls. Cat call, let me tell you, cat call, these are nothing but these are the columns dot. If I go with dot head, then this include all the categorical columns. So we have performed the data pre-processing data pre-processing on the we have performed data pre-processing, but after that I need to change some columns here. You must be thinking of this column is not looking good, so we need to convert it into, we need to change this column to, so we will do df dot rename, add the rename, we will go with the columns, add the columns. What we will do, we will replace this column with, okay, we will replace this column with the suicide. Suicide, I think, if I, okay, then we will use in place is equal to true. I think this will be done. Okay, now if I check it here, it has been done. Yes, it has been replaced with the suicide. So I will also mention here scaling the columns. We have scaled the columns, scaling the columns, we have scaled in a sense, we have made it family history of mental illness. We will also convert this column, let's you can say rename this column also. So we will take the same data set here, we will just paste the name and replace it with the name which in which we want. Okay, so let me paste it here, and we will go with the mental illness history, mental uh, illness history. Okay, okay, so family history. So if you go with the family history, then we'll convert it into mental illness history. Now it looks like good. Now what we will do, we need to do some feature engineering. Now what we need to do, so we need to do some feature engineering. We will select those features that are good for our model. Okay, so what we will do, let's talk about the, first of all, check the relationship of all these columns with the depression. Okay, depression, let's check about the relationship of all these columns with the depression. So here we can say work pressure has no relation with the depression. We will remove the work pressure here. Now if I think that dietary habits is more correlated and suicide is more correlated, 36%, and all these columns are more correlated. Just to show it in a better way, you can go either go with the heat map here. You can study it with the heat map, where I will go with df dot correlation. It will actually create a relationship between each column. Okay, it will take a not is equal to true. Okay, let me see here. If I go with here, now it will take some time, and it after that it will be shown to you. Now it's doesn't looks like it doesn't look stable, so stable. We will go with the plt dot figure, plt dot figure, and we will take the fixed size as 18 by 7. Okay, okay, yeah, we did not close that. Yeah, I've actually came to know about a meme which is called and if you see, work pressure has not that effect on the you can say on the depression. You can read the here, and you can see here, you can see depression with the suicide have more correlation, suicide with the depression have more correlation. 47% you can say work pressure, academic pressure have more correlation with the depression. So you can say that depression value will be changed with more with the suicide and work academic pressure. These are the two columns which are quite important. Academic pressure, let me see some more columns. If we go dietary habits are also take 21%, they are correlated, and other columns are not that good. So first of all, we need to remove we need to select the best features for our model. We need to first of all delete the id, and also we don't need id, it is actually a unique thing, and we don't need id, I think. We will take id here, and also we will remove with the id also we'll remove the what was that, what was the column, work pressure. So we'll go with the df dot drop. Here we will remove columns as id, and the next column is the, we will go with the work pressure here, work pressure. Okay, we will remove the work pressure here, and here I will put axis as 1. 1 means column removed from column, and in place is equal to true. So when I ran it, it will remove all the columns. And let's go with the another thing. Okay, now we also need to scale we first of all need to scale all the columns, which needs to be scaled. Okay, which also we need to scale all the columns here, but I don't think we need to scale in case of linear regression. We can also do in the random forest, since we will using the random forest or some more advanced algorithms. So I think if you did not scale them, then it will also work better. So first of all, we need to since our data set is ready, we need to divide the data set into training and testing. Divide uh, divide the data set into train and test. Okay, so we will divide the data set into training and testing. First of all, what we will do, we'll go with the x train, y train, x test, y test. Okay, so we'll go with the train test split. uh, okay, sorry, I did not import the train test split, so that's why it's not been showing the from sklearn dot pro model selection. Import train test split. So what I will tell you, train test split. Okay, so we will import the template split here. First of all, we need to take the x value. What should be the x value? All the values apart from the depression. So I will make a logic here, df dot drop depression. So what this logic will do, it will not remove the depression, but it will take all the values apart from the depression at x, and after that at y we will only take the depression at x, at y. Okay, then after that we need to select the test size. Test size means how percent of data we want at test. I mean 25% data can be used for test and 75 for training. Okay, and random state means data shuffling. Shuffle the data 45 times. Okay, so random is good when you have random state is very good when you don't want any type of bias. So it will 45 times randomly shuffle the data. Okay, now let's import the algorithms here. Import uh, the algorithms. Okay, now let's try to from check with the linear regression. So what will work when we do with the linear regression? From sklearn.linear model, import linear regression. LG is nothing but linear regression here. Oh, sorry. We will go with the logistic regression since it's a classification problem. So we'll go with the logistic regression. Okay, so we will go with the logistic regression. Okay, I actually forget about whether it's a classification or regression task. I forget about this thing. Okay, I'm sorry. So here we will fit on the data lg dot fit. We will fit it on the data x train and y train. We will fit the data. Or if you don't know about these things, you can watch my previous videos. You will come to know about these things. Okay. Now we need to perform the prediction. Okay. X train. Oh, sorry. I actually forget about X test should be before the Y train. Y train. It should be X train X test and Y train Y test. Sorry, I forget about. So we will fit it on the data here. Okay, it has been fit. Now we need to perform the data on the X test prediction. We will perform the prediction on the X test. Okay, now we already have the values of x answers of x test at y test, so we both will compare it. So we'll import the matrix, performance matrix. We will go with the accuracy first of all. If accuracy is good, then we can go with the um, classification report. Okay, from scikit-learn dot matrix, let's go with the classification report instead of accuracy. Import classification report. If you want that I made a separate video on classification report, then I will also go with the classification report. So you will go use the print function here. So if you use the print function, then stably it will import, it will can say give you the output. Why print and why test? You can also check it without print, then you will come to know. So our accuracy is this case 85%, which is quite good, but we don't want 85%, we need to improve it some more. So here I will use a hyperparameter tuning to determine the best model for prediction. Okay, so what I will do, we will import first of all, I think I lost my Wi-Fi connection. I lost my Wi-Fi connection, I think. Also, I have downloaded, I want to download it, the operating system, and it has not been working. Okay, so what we will do, we will take first of all we will import the mm, all the models, import all the models. Okay, so since we are importing all the models, so what we will do, from sklearn dot dot logistic regression dot linear model, we have already imported the logistic regression, I don't need. From sklearn dot neighbors, import k neighbors classifier. Okay, from sklearn dot bias, was that okay, okay. From dot naive base, import Gaussian naive base. Gaussian naive base is used for you can use it for the two categories. You can either go with the Bernoulli or something else, but I will go with the Gaussian. Okay, go from sklearn dot what's the next algorithm, dot ensemble. We will not use the support vector machine, I think it will take more time. Okay, and I don't have that GPU, so you can either go with the, also with the ensemble, one of the, you can say you can also go with the support vector machine. Gradient boosting, what is the gradient boosting? Why it doesn't show me gradient boosting classifier? From okay, sorry, from sklearn dot sklearn, not dot sklearn. Okay, now we will create a function in which we will import all the models. We will create a dictionary here in which we will import all the models. Okay, so in that dictionary we will import all the models here. So the first model is the logistic regression. We'll put it as logistic, and we will okay, logistic regression, and we will call it here. Then the second is the naive base. I will only put naive here, and we will go with the Gaussian NB, and here we will go with the random forest, random. We'll go with the random. I will only put random here because I think it will work for me better. And then I will go with the gradient. It will take some time to read, to write all these things, and since I don't want my video to be the okay. So since we have imported all these models, now let's create, now we will use the, let's also import the grid search CV, for the grid search CV. So what we will do, we will, it will check all the possible combinations of different parameters, and it will give me the best parameters for my model. Okay, it's called the hyperparameter tuning. From sklearn dot model selection, import grid search CV, grid search CV. Okay, now let's create the parameters. We also need the parameters in which we want to check our model. So first of all, create a parameters tab, and then parameters tab, take the first model as logistic. What is the first model? Logistic. Make sure the name matches with these names, and then again create another list, and here you will take the parameters. So the parameters we used for the hyperparameter logistic is C, and we will check it from 10, 20, 50, 100, 150, and 80. We will check on these values. Okay, now the second is the, we will copy it. The second is the naive base. The second is the Gaussian NB. Second is the Gaussian. Sorry, it's a naive base. Naive. So if uh, uh, if you don't, let's check the, you can say the parameters of naive base in the variable smoothing. Okay, you can take this parameter. Okay, and we can also go with the 20. It's mathematical notation, 1 ki power. We will go with 30. Okay. Okay. So the third algorithm is the random forest. So at the random forest, we will take the, it will, what we will do, our model will do, let me tell you again, it will check the model, it will check the model on each parameter. Okay, on each parameter. Okay, so the first is the n estimators. N estimators means how many trees do you want to use for the random forest. So in the n estimator, we will take first of all 50, then we will take 100, and then we will check it on 150. Okay, and an estimator, again, the second is the max depth. Max depth, it will tell you that what should be the depth, what should be the depth of our, you can say, random forest model of our tree. Okay, so it will be one, either go with 2, 3, 4, 5, 6, and 7. It will check on each depth. Okay, then this, the last model is the gradient, and at the gradient. Okay, so at the gradient, we have, okay, so at the gradient we have the first parameter as, again, it's an estimator, so we will copy that parameter, paste it here, because these parameters are same. It's at the ensemble technique. So this parameter is, and max depth is also same here. Max depth is also same here in gradient boosting. Okay, and the third one is the learning rate. Learning rate, now it's one of the important thing. It is used for optimizing the, it is actually used in with the optimizers. And I, first of all, I will take 0 0.1, 0 0.001, 0 0.001. If you don't know about learning rate, then you can search it. Okay, now I will create a function for model name, model in models dot items. What we will do, it function it this function, it will iterate to model dot items. The first name, it will assign it to model name, and the second, it will be a model. So here we will import a grid search cv here. Gr is equal to grid search cv, sorry, grid search cv. And in the grid search cv, the first thing will be a model. So what, where we will pass, we will pass the model, all these models we will pass. And this, these are actually called the model names. So in the logic, I will go with the params model name. So if I use parent dot model name, then it will take that model name, and will take the each parameter of these model names. It will check it on 8 parameters. Here I will use the cv. C means cross validation. I will also make a video on cross validation. It actually shuffles, it performs the training and testing after shuffling the data. Okay, after performing the shuffling, we will take the cv as 5 times. It will take the different data for the training and testing. Okay, then we have a scoring. So scoring means on which parameter do we want to determine the best model. So with the help of accuracy, we want to get the best model. So we will fit on, now we have created the object, and we will fit that object on x train and y train. And then after fitting the object, what we will do, uh, we will okay, what we will do, okay, we will print the best parameters. We will first of all print, we will use the print function as f best, the model, the, at the place of the model, we use the model name, the model, the model name. Okay, with best params, and the parameters, we will do gr dot best params, and with score, and at the place of score, we will use gr dot best score. Okay, So I will exit this and I will run it here. What was not closed? Yes, I remember it was not closed, so that's why it gives me an error. If I run it here, then it will run. Okay, it will take some time. It will take some time. It will check on every uh, every model. Okay, it will check and it will tell me. Okay, so we have the logistic regression with the best scores of 84 and the value of C is 20. We have the uh, naive base with the best score of 83 with the best score of 83% of accuracy, and the var smoothing is 1e minus 0.9. It will also take some more models, check some more models. Since we get the result of two, we get the result of logistic and naive base. We will also get the result of random forest. These are actually the few parameters. You can go to the documentation and you will check this model with all the parameters, with all the possible parameters. Okay, it depends upon you. Let's wait for some time. I will also pause the video. So since when I will get the report, I will tell you. We have get the answer of random forest. It is 83% of accuracy with max step 7 and estimator as 150. You can check the convert the scoring rate into F1 score, or either you go with the precision, or you can go with the recall. It depends upon you. It all depends upon you. Okay, so it will take some time with the gradient, or with the gradient boosting, and also with the random forest. You can either use convert these cities or all these values into scale it with a standard scaler, and it's your work. I will also and after check you will after check you have to check it with all the algorithms, and then you will tell me that whether these algorithms work for you or not. Okay, so it will take some time. It will take some time. We will wait for some time, and after that we will come to know about my answer. I'm pausing the video just for your ease, because I don't want the things to be little more late, because it's already 27 minutes video. So it will take some time. So I will pause the video. Then after that, I will come to you that what has just happened. Okay, so we have got the best score with the gradient boosting, and now we will use the best model as gradient boosting, the best model as gradient boosting classifier. And in that classifier we will use the n estimator as 150, and the learning rate should be zero point 0.1. I think it will be zero point 0.1, and the max depth should be 2. Okay, you can use some more parameters to get the best accuracy or best model dot predict. Now let's check, let's predict what we want to predict. We want to predict the x test, and then we will compare it. We will get the answers and we will compare it with the y test. Okay. Sorry. I did not fit the model. So we need to fit the model first on X train and Y train. Okay, X train, Y train. Okay, so it will take some time, and at the end we will print the classification report. Okay, we will store it in Y predict. Okay, now we will compare it with the okay Y predict with the Y test. Y predict are the new answers of X test, which has been calculated using this model, and Y test are the actual values, and Y predict is the predicted values. So we will find what's the difference between what's the accuracy between the Y predicted Y test, and what's the difference between Y test and Y predicted. Okay, so if I run it, the accuracy is 85%. Okay, and we have a good precision and also recall and also F1 score. So this is our probably the best model. You can use some more parameters to get the best model. Now we need to store that model into a pickle file, and then we will make a streamlit app in which will contain the deployed model. Okay, so what we will do, we will go with the best model dot okay. First of all, you import the joblib. Joblib is the library which convert into a pickle file. Joblib.dump. We'll joblib.dump, and at the dump, first of all, we will we will give the repository in which want to save the model. We want to save the model in the same repository, but with the file model.pickle. And then what is the model? The model is the best model. Okay, so if I save it here, then it will be saved. Okay, 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 okay. File second argument is the file like object. Okay, I think firstly we will have to select the model. Actually mix up these things. We will first of all select the model, and then we will use the open. We'll use the open model.pickle. It is our repository, and as write binary. And if I want here, so it will be saved. Now our model is saved. When you go into the home, here we got our pickle file. Now it's the second video. In the last video, I will deploy my model to the Streamlit. So it's a request to you to make sure to subscribe my channel, hit the bell icon, and wait for the next video. There I will also give you some sort of more models which you can use, or which you can use for your portfolio, and it's one of the best project here. And we will predict in the future videos that what is the main reason behind the depression, whether the student will experience the depression based on the few values. Okay, so till now, bye bye, Allah Hafiz.